acceleration. Newton's second law of motion. An object accelerates relative to the force applied and in the direction of the force. The greater the force applied, the greater the distance traveled, and the higher speed achieved. Okay? So, as we discussed in the last slide, the larger foot with the shoe had more...
Mass.
Had more what?
Mass.
Mass. The larger foot with the shoe had more mass and therefore generated more force. All right. Therefore, giving the ball greater acceleration. Okay. I'll give you a minute to finish, to complete that, and we'll move on. So when you guys are playing soccer, are you going to start wearing big leather boots?
No.
No? Finish up.
Be done.
Okay. I know many of you are. Yes, Jasmine. Pardon me?
Yeah.
Just what you see circled. I'll tell you what, let's move on, and if some of you need to finish up, you can look at a friend's notebook.
No, wait. Un ratito. Only 1 minute, mister.
All right, here's the next one. Which one, listen up, shh, which one requires more force?
Second one.
You can look later. Look. Okay, in the diagram, in the picture, we have two vehicles. Behind each one, there's a person that is attempting to push it and make it move. And the question is, which will require more force to move it? Which person will have to move, or will have to push harder to move the vehicle?
This one.
We have the blue car and the orange van.
Orange.
Okay? Raise your hand if you think that the orange van will require more force. Raise your hand if you think the blue car will require more force. Again, many of you did not vote, but those of you that did were correct. The van will require more force to move. And why is that? It has more mass, okay? Now what we need to do is, everything below the line needs to be in your notebook, even the little drawing. I know you guys are really artistic. I think you can draw that.
I cannot.
Okay,
Everything?
yes. And while you're drawing it, we'll discuss it a little more. It says which one will require more force, and we correctly chose the orange van, which weighs what? What's its weight? Its mass. It says on there. Someone tell me. 2,000 what? 2,000 kilograms. And what about the blue car? 1,000 kilograms. So using the numbers that we see here, can we calculate how much force is going to be required for each one?
Yes.
Yes, we can. How can we figure out how much force exactly will be required for each vehicle? What's the formula?
V1, V2?
We talked about this. You do not have to write this.
V2 minus
No, you're thinking of some force equals what?
Más,
This about time?
más,
Acceleration.
No.
más,
Jasmine?
más.
My time was acceleration.
Thank you, Jasmine.
You with that.
Hey, mass times acceleration.
That was me.
All right? So, what would we multiply for the blue car to arrive at the exact force? What numbers? 1,000 times 1,000 times what? 0.05. Jacqueline, if you would please let us know the force required for the blue car, and Joe, if you would calculate the force for the orange van. And when you have it figured out, would you go write it above each one, please? I have a marker right here that you can use.
It's gonna be 50.
Mm-hmm.
50.
Yes. Mm-hmm. Force equals mass times acceleration.
Where are you?
Just write the answer if you would please, right there. You don't need to write out the whole problem. Or yeah, why don't you? That would be a good idea. Just write it out for us, please. What did you multiply? It's 0.05.
Yes, please.
0.05. Try it again. I think you did 0.5.
Oh, Ignacio.
It is 50. No. It's 0.5. But it's 5.
It's 0.05, not 0.
Punto 05.
Se encanta.
No es 0.5, es punto 05 ya. Punto 05.
¿Qué traductora?
What do you got, Joe?
Está güey.
Okay.
I got 50.
There you go. Thank you. 50 what?
Newton.
50 force. We're talking about force. What's the unit for force? You know, like we've been doing on all of our do nows with the arrows.
Newton.
Yeah. And just to make it complete, what about the direction? Can you give us a little arrow up above? There we go. Thank you. And Joe, would you please give us a similar information for the orange van?
La mujer de negro. Ella. Igual que vos.
Gris y negro.
All right, very good. How are we doing? Everyone have this? Can we go on?
So we can write down.
You don't need to write down all of this, just, you don't need to write down what the students put up here. Let's get this though. The orange van will require more force because, you guys got it? Raise your hand if you're done.
De hora.
You got this, Mahmood? Got it all done? Regine? Done? All right, we'll come back to it if you need to.
More. More que.
Hold on, guys.
More más de acuerdo. More for because.
Okay, we don't need to write this one, let's just discuss it, let's talk about it.
More.
Ms. Os, would you please read this for the class after you've closed your computer? Can you read it for us, please? Yeah. If kicked, accelerate. Thank you. If kicked with the same force, which ball will accelerate more?
Small one.
The big one.
All right, we have a small soccer ball and a larger soccer ball. Let's say for the sake of discussion that they're both being kicked with a force of 50 newtons, okay? Large ball's kicked with 50 newtons force, and the small ball also
Small ball.
kicked with 50 newtons force. Which is going to have the greater, which is going to accelerate more? Which is going to go a farther distance?
The big one.
Raise your hand if you say the larger one, the big one.
I can't do it.
Raise your hand if you say the small one.
Small.
In this case, and I can understand your logic why you would say the large one.
Yeah, it could.
Because, right, you think it has greater mass, it's going to have greater inertia. But in this case, it's going to be the small one.
Why?
The small one will have more acceleration because
No, the small one, no.
it has what?
I can move on the big one.
It's the same thing we've been talking about. It has
Ah,
more mass or less mass?
both have
Less mass.
Let's do the experience, man. Good.
Okay. Here I have 2 cups, okay? would you take this pencil movement and tap this cup at the bottom? Just tap it once. Okay, very nice. Now, would you attempt to tap the other cup with the same force? Oh! Which one accelerated more?
Man, that one is plastic, bro.
That cup.
It's plastic. That one. Yeah, of course.
So
But
Fabrice,
the boat is kind of the same.
Fabrice, you're contending that because it's a different surface,
Yeah. Of course.
it had less.
Más.
No, the surface. We're talking about the surface.
Force.
What force deals with surfaces rubbing together? We just talked about it. Gravity and friction. Fabrice is contending that there's a difference in friction. And so this cup moves more easily, and that's why it accelerated more. And that's very sound logic. You make a very good point. That really shows you your thinking. And I wish that I had two cups of different mass that had the same surface, but I don't. And what you're saying, the friction did come into play on that to some degree. You're correct. But for the most part, the acceleration was more because it's lighter, it's less mass. Okay? All right. Thank you. Very nice. Fabrice, I like the way you're thinking. I really do. Okay. So, the smaller ball will have more acceleration because, tell me again,
Less más.
less mass. Okay. Write that down.
You're thinking about.
Here.
Mr. Marco, you're thinking about more. But the big ball will move. Okay, I give up.
The small.
I give up.
All right. There you go. Write all that down, please. Yes.
Only answer.
All of them.
Everything from the line below the line. Okay? Here, Mazos and Amisi back here still debating the last slide. You don't agree? Well,
They never get uniform. They just say like we're gonna get uniform next week. Next week. Everything have a uniform.
maybe you can write your theory at Y down and we'll discuss it further. Got this, Regine? Yes? Giancarlos? Giancarlos? Got it? Done? Okay. All right, guys, let you copy later. Okay, no need to write anything on this one or to draw. With the van and the car, the objects were being pushed. A force is a push or a pull. A force is a push or pull. What's going on in this one? They're pulling. They have 2 rocks, each one is tied to a rope, okay? And they're pulling them. Mahmood, would you read it for us, please?
Yeah, both rocks move with an acceleration of 0.5
Meters
meters
per
second.
where?
Square, yeah.
Go ahead.
Which rock will require more force?
Okay, we have a large rock and a small rock. And they're going to move with an acceleration of 0.5 meters per second squared, which will require more force to achieve that acceleration. Raise your hand if you say it's the large one, the big one, that's going to require more force. Only 1 vote. 2.
Can say that too, but
Now we're up to 3. Who says that the small one is going to require more force? Well, just for the same reason that the van required more force to be pushed, the larger rock is going to require more force to be pulled. And why?
more
The
mass.
large rock will
Has more mass.
because it has more mass. Okay? Any questions? Let's look at another one. Actually, this is your exit ticket here, guys. I'm going to put a video on, and your exit ticket is to write 5 facts from the video. Or not, 5 scientific words. 5 scientific words from the video, okay? Like mass, acceleration, force, those kind of words. Five scientific words from the video. Hold on. This is not the right. This isn't the right video. I'm sorry. I'm sorry, guys. I had this earlier, and somehow it got deleted, and I can't find it. Here it is. Here we go.
It's for kids.
Well, you are
Now let's
kids.
move on to Newton's second law.
I wish I was a
We
kid.
know from the first law that to overcome the inertia of an object, we have to apply unbalanced force. Newton's second law talks about how fast an object would move. Well, it states acceleration of an object depends on the mass of the object and the amount of force applied. In mathematical terms, Newton's second law states that force is the product of mass and acceleration. To cause an object to accelerate or speed up, a force must be applied. The more force you apply, the quicker you accelerate. Look at these two swings. If you apply the same force on both swings, check whose goes faster. Let's first push the little kid. See? It goes very high. Now push this fat man with the same force. See, it does not go far because it has more mass than the little kid. So the more mass there is, the force required to push the object is also greater. Let's look at the mathematical formula of the second law again. It's the product of mass and acceleration. We've already learned that if there's more mass in an object, to move it, we need more force. Now let's see this kid sitting in the swing. If we apply a little force, then it goes a small distance. Now if we apply a lot more force, it goes very high. So to get more acceleration, we need to apply higher force. So now you can understand the relation among force, mass, and acceleration.
All right, we're going to watch it again.
I don't even have four.
Now let's move on to Newton's second law. As we know from the first law that to overcome the inertia of an object, we have to apply unbalanced force. Newton's second law talks about how fast an object would move. Well, it states acceleration of an object depends on the mass of the object and the amount of force applied. In mathematical terms, Newton's second law states that force is the product of mass and acceleration. To cause an object to accelerate or speed up, a force must be applied. The more force you apply, the quicker you accelerate. Look at these two swings. If you apply the same force on both swings, check whose goes faster. Let's first push the little kid. See? It goes very high. Now push this fat man with the same force. See, it does not go far because it has more mass than the little kid. So the more mass there is, the force required to push the object is also greater. Let's look at the mathematical formula of the second law again. It's the product of mass and acceleration. We've already learned that if there's more mass in an object, to move it, we need more force. Now let's see this kid sitting in the swing. If we apply a little force, then it goes a small distance. Now if we apply a lot more force, it goes very high. So to get more acceleration, we need to apply higher force. So now you can understand the relation among force, mass, and acceleration.
One more. This one's a good one.
My name is Cassidy. I had an epic idea for a prank. Fill a friend's car up with Maltesers.
Let's learn Newton's second law of motion. Newton's second law of motion.
5 words.
Before understanding Newton's second law, you must know about acceleration. It is the rate of change in the velocity of an object. The second law of motion states that the greater the mass of an object, the more force it will take to accelerate the object. There is an equation. Force equals mass times acceleration, or you can say F equals m into a, where F is the force and its unit is Newton. M is the mass and has the unit kilogram, and a is the acceleration, which has the unit meters per second squared. In simple language, Newton's second law states how fast an object can move. This also means that the harder you kick a ball, the farther it will go. Oh, it seems you are not understanding this. Your friend is on a skateboard. You push him forward and he begins to move slowly. Now, a big push, and see, he moves faster and gains speed much faster. Now your friend gets in his car. You push the car, but it is so hard to move. You pushed harder, and it barely begins to move. Oh, and now you are pushing it with some other friends. See, it moves faster and faster.
wants to share? Yoselin, tell me the words that you wrote down, please. Say it again.
Let me do them.
Joe? Good. Velocity, force, mass, what else? Acceleration. From the videos. What did you write down, Mahmood?
Acceleration, mass, velocity, and inertia.
Okay.
And force.
Yeah, I said force.
All right. Okay, Analo, have a question for you. What's the formula to calculate force?
Can I do it?
Just up there, you pay attention. Fabrice,
Mass time of the acceleration.
mass times acceleration to calculate force, okay?
Almost.
All right.
Yes.
Shh. Amisi, Newton's first law of motion is also called the law of what? Newton's first law of motion is also called the law of... Raise your hand if you can tell me. Guys. Starts with I. Inertia. First law of motion, also called the law of inertia. All right? Joseph, Joe, what is the formula to calculate speed? Distance divided by time. Okay. Let's see here. Who's next? Mizos, what's the formula to calculate acceleration? V. Yeah? V2 V2 minus V1, keep going, over T2, T2 minus T2, T1, V2 minus V1 over T2 minus T1. That's the formula for what, Nubia? V1 minus V2 divided by T1, I'm sorry, T2 minus T1. That's the formula for what? Thank you, Nubia. Acceleration. Okay?
That was me. A few seconds I would say.
Samson. Shh. Quiet, guys, please. Samson. Newton's first law of motion is also called the law of... Said it just a minute ago. Starts with I. Inertia.